Hi everyone, welcome to my channel. My name is Fikret. This video continues tutorial series dedicated to learning Microsoft Fabric. In the last tutorial, we explored two great features of Delta Lake technology. That's time travel and change data feed. It turns out you can use these technologies in combination of another great technology called Spark Structure Streaming to build real-time analytics systems based on your continuously updated Lakehouse tables. Join me to learn more. This tutorial comes in two parts. In the first part, we are going to build low-latency streaming pipeline that will read from constantly changing Lakehouse tables, apply some transformations, and write into destination table. In the second part, we're gonna build real-time alerting and monitoring system that will react to the change in your Lakehouse tables. Here's a quick preview of what I'm gonna cover in the first session. We'll start by discussing different data engineering challenges of building streaming pipelines in Lakehouse. There are a number of challenges, including what tooling to choose to ensure low latency. How do you identify deltas in your source table? How do you merge into destination tables? We'll discuss potential solutions for that. Then we'll move to a demo section where I will show how to enable change data feed on Lakehouse tables. Then I'll demonstrate how to apply some data transformations like joining, line calculations on your streaming data frames. Then we'll discuss deduplication logic, which is important when you are merging into some destination table. Next, we're going to discuss how merge into logic can be implemented on Spark structured streaming. Then we'll wrap up the discussion with the validation of real-time pipeline. Couple of quick notes before we proceed. This tutorial is heavily relied on a few important technologies like Spark structure streaming, change data feed. If you are not familiar with that, I would strongly recommend you to take a look at a few videos that I will include in the video description, as that will help you to understand these materials better. Also, if you are new to the channel, please take a moment and subscribe. Your support is valuable to me, and it will help you to stay up to date with my latest videos. Let's get started. Let's talk about some of the typical data engineering challenges that are involved in building low latency continuous pipelines in Lakehouse. One of the first questions or challenges is to what tooling and the technology to use that will include reliable logging mechanism that's resilient. Microsoft Fabric comes with few real-time streaming technologies like Event Stream and KQL. Unfortunately, none of them are capable of reading delta tables, at least at this point. So Spark structure streaming could be an answer for that. So this is a great technology that uses its internal logging mechanism to track the change in your data source. It is resilient and it's based on programming APIs that are very similar to batching APIs. However, Spark structure streaming is good for append-only tables mostly. So if you try to read from tables where your rows are being updated and deleted, you'll quickly find that that idea doesn't work. So Spark structure streaming will break, and that's by design. So how can we resolve that? Instead of reading from table directly, we could use change data feed to read changed data only. So the change data feed is another great technology which can be enabled on selected tables, and it's also based on its own internal logging mechanism. Great thing about change data feed is you can read the change data using batch APIs as well as streaming APIs, which will be very similar to Spark structured streaming. So basically you can use combination of change data feed and Spark structured streaming to identify your change and streaming to any destination. Another challenge when you are dealing with streaming pipeline is how to merge your change to the destination table. Spark structured streaming can write in the destination tables in either append or complete mode. So complete mode is similar to full, truncate, and the load methods. So as you can imagine, neither of these methods will be best when you are dealing with large tables. So ideally you want to update only changed rows instead of entire table. Using ForEachBatch destination in Spark structured streaming can solve this. The essence of this method is you can create Python function that will be called for each micro batch. So Spark structured streaming is based on series of micro batches, and by using for each batch you can basically call certain Python function for each small portion of your batch, so micro batch, and within that function you can use any static data frame methods including merge. So we talked about using change data feed to identify change in your data. However, one of the challenges related to that is you may have same rows being updated multiple times. And when you try to transfer a batch of rows which contains multiple versions of the same changed row, you will not be able to use merge into logic, because that logic requires that your source and the destination rows were unique within certain primary key combination. How we can solve that? We can use window functions for that to deduplicate your rows and keep only latest change feed. Alright, I am in Microsoft Fabric and I opened one of the Lakehouses I have created earlier. For the purpose of this demo, you will need to have two artifacts. Data file in the format of Parquet and the PySpark notebooks that you can see on the screen. You will find both of them in the video description. Please download the data file and upload it into unmanaged section of your Lakehouse. And once uploaded, you can take relative path and put in the first command on the load method. I already run this notebook end to end. So this notebook is repeatable. You can run it as many times as you want. And then once I read the Parquet file, I write it into stocks delta table within my Lakehouse. So my next command takes a look at the sample of this data. This data represents stock exchange data, which I created from sample input data for event stream, and I applied certain cleaning and massaging on this data set. So you can see that I added currency column here, which I need to demonstrate join operation as part of sample transformation. My next command creates small lookup table named exchange rates and populates it with a single row for USD currency. And next command reads this table, assigns to DFR data frame, which we'll be using down the road. And here's how my data looks like. The first step in creating real-time analytics solution is to take care of your historical data because real-time analytics pipelines are usually taking care of your delta, so change from certain point. And for that, I created this command, which selects subset of column from the source table, applies some sample transformation. So in this case, it just calculates converted exchange rate, and it writes in the destination table. So my destination table will be called stocks process table, and here's a sample data from this table. Okay, now that we have taken care of our historical data, let's take a look at streaming part. My next command enables change data feed on the stocks table, and then I'm using describe history table, and then I'm using describe history on stocks table to see how many versions we have and from which version my change data feed is valid. So you can see that my set table properties operation corresponds to version 1. So this is a version from which we can query our change data feed. So I assign this value to the variable so that I could use it down the road. And then I use sample update, delete, and insert transactions on my stocks table. Now that we have change data feed enabled, let's inquire the change data feed. So that's what my next command does. So I included change data feed and the starting version options here. And I'm using this variable that we created earlier as change data feed starting value. So here is how my data looks like. For the most part, it's the same data that comes from source data. However, change data feeds adds 3 metadata columns here. So the change type and the commit versions are important columns that I'm going to use in my streaming solution. Change type shows what transactions have been applied. So you can see that we have feeds for insert, delete, and update. Update transformation generates 2 change feeds, one corresponding to the state of the data before, another after the change. As the name suggests, update post image represents the latest version of the data. Each transformation type needs to be handled differently. Another thing to notice here is that commit version is ever increasing number. Higher the number is more recent transaction it represents. Okay, so let's scroll down. My next command assigns variable names for destination table and the path. And I clean up checkpointing folder for my streaming. You can skip this command if you are running Notebook for the first time, but I included here just in case you won't run it multiple times. And that's because checkpointing folder contains the logs and the progress of your stream. And if you run it multiple times with no change to your data source, your stream will not do any progress in subsequent runs. My next command is also optional. I included here data frame with same transformations that you will be seeing in streaming part. So as I mentioned earlier, my streaming will be based on ForEachBatch logic, and ForEachBatch function will contain all the transformations that you will see here. And the reason I included this command here is that it's easier to see and browse all the results of these transformations on a static data frame. Let me walk you through different parts of this command. So on line 6, I am applying filter to exclude all the pre-image states of feeds. In this case, I am not interested in before transformation states. And then I have deduplication logic between lines 8 and 10. So I use raw number function, which is one of the PySpark SQL functions. And within that, I use window function. So I use combination of primary keys as a partition. And I use commit version to sort out my data. Notice that I'm using desc method here so that my rows are ordered on descending order, and I then filter out all the row versions beyond version number 1. And here is how my data looks like. Now let's take a look at core streaming logic. So I have two commands for that. My first command creates ForEachBatch function. So in this case, I call it merge batch. For each batch function, you need to supply two parameters: data frame, which will represent a portion corresponding to each micro batch. So if you are familiar with streaming, you know that streaming is nothing but series of micro batches, and each micro batch will be passed from parent stream to this function, and batch ID will represent that micro batch ID. In this case, I am not using this, but you can use it for a number of purposes. Within this function, I have two commands. My first command deduplicates source rows from df data frame using similar techniques that I described a little earlier. And my next command uses merge method of delta table object that I have created on line 4. So delta table object is another way of handling delta tables, and to use that you have to include the delta tables library. Let's take a close look at this merge logic. So here on the line 9, I'm specifying comparison condition, which is based on 3 primary keys. In line 10 and 11, I am handling matching conditions. So in line 10, this is match, and I am handling delete operations. So to determine if rows need to be deleted from the target table, I am checking change data types value. So, and if it's delete, corresponding row will be deleted from the target table. And similar command for update, except in this case, I am checking for post image change data feed type. Line 12 takes care of new rows, and in this case I am saying insert all the new rows that are not presented in the target. Okay, now that we know how for each batch function is designed, let's take a look at streaming command itself. My next command creates streaming and applies similar transformations that we have seen earlier. So basically I filter out all the update pre-image rows, and I join against the lookup table. Then I select this subset of columns. These are similar transformations that we have discussed earlier. The bottom part of this command contains methods necessary for write stream API. So line 13 assigns the name for this stream. This is not mandatory, but it makes it easy to manage your streams. Then this is the most important part. So on line 15, I am using for each batch method, and I specify the function that we have discussed a little earlier. And then line 16 is just standard part of any streaming application where I specify checkpointing location. And my next command starts the stream and assigns the results to stream handle variable. Once the stream started, you may want to wait few seconds and then run status method for stream handle variable. So that's a good way of to understand what is streaming doing at the moment. So you can see that in this case it's processing new data, so that means that streaming is working well. The streaming may fail because of different reasons, and I found a status property is one of the best way to troubleshoot it. Now that we have streaming pipeline running, we can test this logic. So I have included update transformation here to increase bit price. And my next two commands inquires the source and the destination table. So destination table is here for the same subset of rows. And as you can see here, values in bit price column are identical. That means that update transformation have been replicated successfully. And finally, my last command stops the stream. So don't forget to stop your stream, otherwise you may get unexpected high bills. This concludes today's discussion. To recap, we have learned building low latency streaming pipeline that would write into Lakehouse tables. We also explored potential solutions for different data engineering challenges when building this kind of streaming pipelines. In the next video, we are going to build real-time monitoring and alerting system. I hope you enjoyed today's discussion. Thanks for watching and happy learning. And I will see you in the future videos.